Hey guys, we're back. I'm here with
On the sofa.
Hey, we're back. I'm Mrs. Opal.
And I'm Annika Opal, and today we're going to be reviewing binomial and geometric.
Distribution.
What?
Distribution.
Distributions.
Okay. All right, let's go, guys. My kids are here. They're coming to help. They're going to be the audience, and they're going to ask questions, and they're going to be great. And now my son's leaving, but that's okay. Annika will help us out, right, Annika?
Yes, I will.
Next. Okay. All right, here we go. So here is your review sheet that I'm pulling up now. How do I get rid of this? No, I don't. Okay, there we go. Now I'm going to make my screen a little bit bigger. Sorry, we just wasted a minute, but we're okay. Right, Annie?
Yes.
Okay. So I'm going to cover up my screen right now. I'm going to move us over to the side. And now we're going to say the probability of the Mets winning a game against the Diamondbacks is 3/4. They're playing a 3-game series this weekend. Check the 4 requirements for the binomial setting are met. The first requirement is B for binary, success, failure. That would be their wins and their loss, success, failure. I is independent. Are games independent, Annika?
Yes.
Yes, they are, okay? Games are independent of each other. It doesn't matter if you lost your first game, you still have a good chance on winning your second game. Doesn't matter. N is the number of trials are fixed. Annika, are the number of trials fixed?
Yes.
How many trials are there, Annika?
3.
Very good. It's a 3-game series, okay? And then finally, the probability of success has to be the same for each one. Annika, is the probability of success the same for each one?
Yes.
And the probability of success is 3/4. There's our bins. Binary win-loss, independent games are independent, N trials equal to 3 games, and S probability of win is 3/4. Now we need to figure out the mean. Annika, do you know what the mean is?
Yes.
The mean is equal to?
2.25.
2.25. She is right, and she got that by taking N times T, 3 times 3/4, to get the right answer. Next, we have to find the standard deviation. Annika, did you find the standard deviation?
Yes.
And what did you find, Annika?
0.75.
She sure did, and she got this from this formula here. The square root of N times P times 1 minus P. And you plug in your N, your 3, your 3/4, and your 1 minus 3/4 to get 0.75. Next, we're going to go on to the problems, which are a little bit more difficult for a 6-year-old to do. So it'll just be Mrs. Opal here for you. What is the probability that a team will win at least one game? At least one game. Whenever you see at least one, you should do the probability that x is greater than or equal to 1 is 1 minus the probability that x is equal to 0. And how we do that then is we have to use our formula for when x is equal to anything. This is the formula you always use for the binomial distribution. So in my calculator, so I'm going to pull my calculator out right now. And if you don't know how to use a like you don't have a nice calculator like this, you need to make sure, hold on guys, you need to make sure that you can get a calculator, and I put a link on Schoology to get a calculator that looks similar to this. Okay, so what we're going to do right now is I'm going to just kind of clear things out to make it look a little nicer, right? And I'm going to type in 1 minus, and I'm going to make a big parentheses like this, okay? So there we go. There's our parentheses. And then we have the 3. So 3. I need CO. So I hit PRB. I go to the NCR, which is 2, and then 0. Then I'm going to multiply that by 3/4. So that's 0.75. Oh, and I forgot the points. I need to go back and change that. Checking along the way. 0.75. And then to the 0th power. Well, how do I do it to the 0th power? Well, a lot of you know that's 1, but just for practice, with our calculator, we should see a little caret top right here to the 0th power. And then I need to arrow over, and then I'm going to do 1 minus 0.75. Well, lots of us know that's 0.25, but in case you can't do it, and you need to actually use that 1 minus, so 1 minus 0.75. to the 3 minus 0 power. So I know that that's 3. So I'm just going to put 3 in there. Okay. And then I'm going to arrow off, and I'm going to close off that parentheses, and now I'm going to hit enter. And your answer should be 0.9844. Okay. And I'm fine if you guys just round to the nearest hundredth. So that's our answer for D. Okay. Let's move on to E. E says, what is the probability that the team will win exactly 3 games? When you see exactly, you should be jumping for joy, because you just have to plug the formula in once. You don't have to do any 1 minus or adding or anything. So N again is our 3. K is actually our 3 as well. The K always comes from the problem. Okay. The N comes from the beginning of the problem, and sometimes N and K are equal. So I fill it into my formula just as it reads. 3 is my total games. I'm curious about 3. That's my K. And so I go to the calculator. 3. Prob. NCR. 2. 3. Parentheses. We know that's 0.75. We do the carry top to the 3rd power. And then here's the deal, guys. 1 minus 3/4. Well, that's 0.25. And then 3 minus 3 is 0. And anything to the 0th power is just 1. So now I'm going to hit enter. And I have 4. Ooh, something went wrong. Oh, do you see what I did wrong? I'm going to go back up here. I'm going to hit enter. I forgot to put the decimal point. So one thing you should know, anytime you're doing this, you need to get a decimal for your answer. And that's how I knew immediately that I was wrong. And there we go. Now let's try it again. 0.421875. So if we round just to the nearest hundredth, our answer here for part E is 0.42. Okay, so now I'm going to scroll down. It says, what's the probability that the team will win at most 2 games? At most 2 games, that would be the probability that they win 0 games, okay? Plus the probability that they win 1 game, plus the probability that they win 2 games. So I have to, this is kind of annoying, I know. We have to fill in the formula 3 times. Each time, oh, I see an error, you guys. I'm sorry. At most means X is less than or equal to 2. I can't win any more. Okay. So I have my K for 0 because that's less than or equal to 2. I have my K for 1 because that's less than or equal to 2. And I have my K for 2 because that's less than or equal to 2. So that's when I need to stop. I plug it all in. 3. Prob. Do it with me, guys. Get used to it. Become one with that calculator. 3. NCR 0. Now we have 0.75 to the 0th power. So that's 1 right here if you're looking at that. And then I know 1 minus 0.75. Well, that's 0.25. And you can put 1 minus in there if you want. To the 3rd power, so that's carrot top. So I did it once right here. Now I'm going to arrow over. Plus 3 PRB, NCR number 2, and now 1 times 0.75, right, to the 1st power. Now I don't need to write the 1st power because it's just going to be 0.75, times 1 minus 0.75, so that's 0.25, right? To the 2nd power, plus, now we're going to do it one more time, 3 C 2 times 0.75 to the 2nd power, arrow over, times 1 minus 0.75, so 0.25 to the 1st power. And now I'm not going to write down the 1st power because I know it's just what it should be. And now I'm going to hit enter, and I get 0.5781. So I'm going to just round that up. This answer right here is 0.58. All right, we're going to move on. I'm not going to do every problem with you, but I'm going to just give you a good binomial review as well as a good geometric review. So here's a good geometric one for you about Chris. Chris's home basketball team has a 33% chance or 0.33 probability of winning any given basketball game. What is the probability they don't get their win? They don't get their first game. They don't win their first game of the season until the 7th game. So that's the probability that x is equal to 7. And here's our formula that we're using for geometric probability. Now, what's the difference from binomial probabilities? Geometric is a wait time until your first success. So we don't get our win until our 7th game. We do 1 minus c, so 1 minus 0.33 to the k minus 1. So our k is 7. They'll give us the k always in the problem. So to the 6th power times 0.33. When I plug that in my calculator, 1 minus 0.33 to the 6th power times 0.33 equals 0.03. What's the probability they don't win their game of the season until the 4th game? Now our K value is 4. Do it the same way. I have 2 more to do with you. What's the probability it takes at least 2 games before they win? Whenever it's at least, that's the probability. You have to do the complement rule. So at least you always want to follow this procedure. I like to write out what's going to happen. I could win my first game, my second game, but I don't want that. It's going to take at least 2 games before they win. So that means they win on the 3rd game, 4th game, 5th game, ... It continues. I don't want to win on my first or my second game. I need to use the complement rule. So I need to say 1 minus what I don't want, the probability that x is equal to 1, plus the probability that x is equal to 2. So now I'm, again, using this formula. Here's my k value and my k value. I do 1 minus. So let's go through it. 1 minus parentheses. Now, 1 minus 0.33, that's 0.67. So I'm going to just go ahead and write 0.67 to make it easier. 0.67 to the, what is that? 0th power. Oh, I don't even need to type that in then, right? Because anything to the 0th power is just 1. So 1 minus, this is 1, times 0.3. So 0.3, and it should be 0.33, guys. Excuse me. I'll do it right in the calculator. So watch here, 0.33, right? So that's this right here that I have 1 minus 0.33 plus, now we do 1 minus 0.33, so I know that's 0.67. You can use parentheses to do that if you need to. To the 1st power, right, because I'm following this, k minus 1, and my k is 2. So 2 minus 1, right? And then I'm not going to write 1, obviously, because it's just going to be 0.67, and then times 0.33. And then I'm going to close my parentheses one more time and hit enter, and I get 0.4489. So let's write that down. This is your answer for C, 0.4489. Okay, we're getting kind of close to the time limit here. Last thing, what's the probability it takes at most 3 games to win their first game? That means we're going to win at the 1st game, the 2nd game, or the 3rd game. I use this formula. I have my k value here, my k value here, and my k value here. I plug it in. I'm going to let you practice it this time and see what you can get. Finally, one thing we didn't address is the expected number, okay? So the expected value when it's a geometric distribution is 1 divided by p. So if I ask you, how long would they have to wait until they, or on average, how long would they wait until they get their first win? We would do 1 divided by 0.33. So let's do that now. 1 divided by 0.33. And that's 3.03. So they'd have to wait on average about 3.03 games before they get their first win. All right, there's a review for you guys for binomial distributions as well as geometric distributions. Let us know if you have any questions. Have a great day.